Hey everybody, today we're going to be talking about moving beyond dominant and recessive traits. So our father of genetics over here, Gregor Mendel, focused on you can either have something that's dominant or something that's recessive. But what we're going to be focusing on is in looking at things that are blended together or things that are speckled. So like what we see at the bottom here. So the first thing we're going to talk about is co-dominance. So if we think about the word co-dominance, there's other words that start with co, like co-ed. If something is co-ed, that means that there's both male and female present, like in this classroom. If we think about a co-pilot, there's two pilots. If I went onto a plane in the cockpit, I'm going to see main pilot and then the co-pilot. Co-captains on a football team, there's going to be two captains present. So we're kind of getting that idea of co-dominance. So if we look at our pictures below, we have a dominant white chicken, a dominant black chicken, and then the mix would be both would be present. So both traits are seen or expressed in that heterozygous. So we have homozygous white, homozygous black, and the heterozygous would be our spotted or speckled. This means that we have three phenotypes and three genotypes. Before, when we talked about Mendel, we only had two. If I was homozygous dominant and heterozygous, I could be brown eyes, and then I would just have the other phenotype of blue eyes. Here, we have three phenotypes and three genotypes or three letter combinations. So again, two dominant, one heterozygous, but both of those dominant colors are showing. So when we write this out, we always write this as capital letters because it is dominant. Okay, the word dominance is in the name, so we're always writing it out with capital letters, no little letters here. Each dominant trait gets a letter to represent that trait or that color. So black would be capital B, capital B. Again, capital letters because we are dealing with dominant. White would be capital W, capital W. Now, the mix or stripes, the heterozygous, it has black stripes and white stripes. So that's how we indicate half black, half W, or half B, half W. So BW. It's not going to get its own letters. It's not that special. It's a mix of the two. So we want to make sure that we have both of those letters present because that's what we are seeing. So here we have three cows. We have three different phenotypes. What could they be? We should see brown, white, and speckled. The speckled is the brown and white mix. Now, out of these three phenotypes, the two dominant traits are going to be brown and white. The speckled is the mix, or the speckled is the heterozygous cow. Again, what notation are we going to use? So, for brown cow, we can use capital B, capital B. The white cow, we can use capital W, and the speckled, because I see both the white and the brown, I can have BW. All right, so we're going to make a key. We're going to take that information we just had and practice our Punnett square. So my key, I have capital B, we said was brown. We have capital W, we said was the white. And then capital B, capital W is speckled. Okay, this is going to be parent 1 up here. This is parent 2. So parent 1 is B, capital B. Parent 2 is capital B, capital W. So I need to create my Punnett square. Separate out my alleles, BB on the top, BW on the side, and then cross my information. Okay. Again, I'm looking at my F1 generation. F1 generation is my offspring. So what genotypes do I have present? I have big B present in those two boxes. I have big B, big W present in the bottom two. This represents brown and speckled. So my percentage, I have 50% big B, and 50% big B, big W. 50% brown and 50% speckled. Sorry, my Handwriting's a little off. There we go. Speckled. Okay, so same way we've done it before. Now, the opposite of this is going to be known as incomplete dominance, meaning it's not completely one color and it's not completely another color. We still have 3 phenotypes and 3 genotypes, but again, one trait is not going to completely overshow the other one. The result is blended. So it's like I took my 2 dominant colors, put them in a blender, and that's what I got. So again, we write all of these as capital letters. Again, capital letters because it is dealing with dominance. So here we have a black fish, a white fish, and a gray fish. The black is the dominant color. The white is the dominant color. If I mix them together, I get gray, which is blended. Okay, so black would be big B, big B. White would be big W, big W. Gray is the blended color. It is a mixture of black and white. So we want to make sure that we're still giving that the 2 letters from our dominant traits. And we want to make sure we have some of it has black, some of it has white. All right, so our practice. We have purple fish, blue fish, and red fish. So what are all of the phenotypes present? Well, what I just said, blue, red, and purple. Which 2 traits are the dominant and which is the blended? We got to think about if I mix 2 colors, what's that new color going to be? So if I mix purple and blue, that's not going to give me red. If I mix red and purple, it's not going to give me blue. But if I mix blue plus red, that gives me purple. So blue and red are my dominant, purple is my mix. We need to think back to kindergarten when we were learning our colors. So notations again. We have the blue fish. Blue fish will be big B, big B. I use B because blue starts with a B. Red fish, I'm going to go with capital R, capital R. And the purple fish, it's going to be BR. Okay. Now for this heterozygous, if you put RB, that's fine too. Doesn't matter which order you go in as long as it's a mixture of those 2 letters. All right, so let's do some practice. We have a white horse and a brown horse. So I would like for you guys to please make a key. So we have BB is going to be our brown horse. WW is going to be our white horse. So if I mix brown, if I mix brown and white together, the color is not going to get darker, it's going to get lighter. Okay, so my mix, BW, is going to be tan. If you put light brown, that's also fine. I want you guys to hit pause and try to fill out this Punnett square and then come back and make sure that you guys have it correct. All right, so my white horse is parent 1, my brown horse is parent 2. We have WW, BB. Put that in my Punnett square. And then fill out my Punnett square cross. Okay. My genotypes that are present, only BW is present. This is tan. Again, I can look at my key to figure that out. I have 100% BW. All 4 boxes are BW. How many of them are tan? 100% are tan. Okay, so again, incomplete dominance is that it is a blended mixture of the 2. Co-dominance, we see both colors, like co-captains or co-ed. We see both things. All right, so when we talk about moving past dominant and recessive traits, we can also have things that have multiple alleles. Now, eye color, we've talked about, it's not just as simple as brown eyes or blue eyes. There are many different color or many different shades. There's different shades of blue eyes, different shades of brown eyes. There's green eyes, there's hazel eyes, okay? So we have multiple alleles, meaning that there's 2 or more alleles. It's not just as simple as big B and little b. Same with all these cute little puppies. We have black labs, white labs, silver labs, chocolate labs, yellow labs. There's a lot of different types of Labrador colors. So when we have multiple alleles or we have more than just 2 letters that code for these colors, it increases the possibility of, or the possible genotypes and phenotypes, meaning I'll have more of them. We're not going to focus a lot on multiple alleles except for just one type, and that's blood typing. That's coming up next. So with blood typing, we have we have four main types of blood. We have type A blood, type B, AB, and type O. Now with A and B, there is a positive and negative. Okay, same with O, there's positive and negative. We're not going to focus on those. Okay, we're just focusing on the four main types. So with multiple alleles, okay, we have four different blood types, A, B, AB, or O. So we have four different blood types, but we have more than four genotypes. So for O blood, we would write this out as little I, little I. For A blood type, you can either have I capital A, or I capital A, I. When we look at this, this is going to be our homozygous version because if you notice, they're the same. And this is going to be our heterozygous version for blood type A. B blood type is the same thing, IB or IB little I. Again, this is our homozygous for B, and this is our heterozygous for B blood type. Please make sure that you guys are writing down this information, this homozygous and heterozygous. And then AB blood type is just IA, IB. Now, we're going to take that information and we are going to try to figure out the genotype and phenotype of these two people. So we want to make our key. So what we pretty much just put down for O blood type, I have little I. For A blood type, IA, IA, or IA little I. For B, I can have IB, or IB little I. And then AB blood type is just IA, IB. All right, so cross a woman who has AB blood type. We're going to underline that. That's our first one. This is parent 1. With a man that has type O, this is parent 2. So parent 1 is AB, but again, we don't write it out just AB, or just like AB. We have IA, IB. Parent 2 is little I. So again, we have two alleles. This is our first allele, this is our second allele. We have to separate them at the top of our Punnett square. So we have IA over one section and IB over another. My second parent, little I, we separate them like we've done before. Then we cross this information. IA drops down, little I slides over. IB drops down, little I slides over. IA drops, little I slides. IB drops, little I slides. So the genotypes I have present in my F1 generation, again, I care about what's in my boxes. I have two boxes that have IA, little I, and I have another two boxes that have IB, little I. Phenotypes, this represents A blood. This represents B blood. I can look at my key and see that. Okay. So what probability will the offspring have? So again, probability is we're dealing with percentage. So type A. So how many of these boxes represent type A? 50%. Type B, I have two boxes over here, 50%. Type O, 0. Type AB, 0. If you guys have questions, make sure you are asking them now. All right, the last thing is our flow chart. Okay, so when we're dealing with trying to figure out if something is dealing with dominant recessive traits or codominance or incomplete, we have to start at the top. If I have two phenotypes versus three phenotypes, so if I have two phenotypes, I'm going to be dealing with three genotypes. Big B, or we'll say big, little, little. If I have two phenotypes and three genotypes, I'm going to be dealing with Mendelian genetics. If I have three phenotypes, then I'm dealing with blending. So I want you guys to write down, let's go red plus white equals pink. This is a form of blending. I apologize for the red line going across. Red plus white equals pink. This is going to be incomplete dominance. If I have 3 phenotypes but both dominant traits, so we can write down spots or stripes. Write down those examples. This is going to be codominance. I'm going to be able to see both colors. So make sure you guys copy that flow chart into your notes, and you guys are going to move on to the practice problems after this page.